Continuing with the fundamental theorem of calculus, we will consider part 2, shown on our screen and listed in our book. If a of x is equal to the integral from a to x of letter f of t dt, then a prime of x equals to d dx of the integral from a to x of letter f of t dt equals to letter f of x. We will start with our example and apply part 2 of the theorem. If letter f of x equals to the integral from negative 3 to x of 3t squared minus 17 dt, we want to find letter f prime of x and letter f prime of 1. Comparing our example to part 2 of the theorem, we notice that letter f of x is a of x, letter f of t is 3t squared minus 17, a equals to negative 3. We will start and compute letter f prime of x. So letter f prime of x is equal, in this case it is a prime of x, which is equal to d dx of the integral from a to x. A here is negative 3 to x of 3t squared minus 17 dt. According to part 2 of the theorem, this is equal to f of x, which is the function replacing t with x. This is going to be equal to 3x squared minus 17. And this is the value of letter f prime of x. We notice that we only consider the endpoint x. This is always going to be the case. We will never consider the endpoint a. In this case, a is equal to negative 3. I will show you why. Let's copy f prime, letter f prime of x equals, we'll bring the d dx down. And now we want to find the antiderivative of 3t squared minus 17. Applying the power rule of antiderivatives for the term 3t squared, we will have 3t cubed over 3 minus, now we apply the special case under the power rule of antiderivatives, and we will have 17t. And we want to evaluate this from negative 3 to x. Notice that 3 here will simplify, and we're left with t cubed minus 17t. To evaluate from negative 3 to x, we will apply part 1 of the fundamental theorem of calculus, which says to evaluate the function first at b minus the function evaluated at a. So this is going to be equal to d dx. And as I said, we will first evaluate the function at b, and b in this case is x. This is going to be x cubed minus 17 times x and now minus the function evaluated at a, which is negative 3, and we will have negative 3 cubed minus 17 times negative 3 What we want to do now, we want to find the derivative with respect to x, but we notice that here the two terms don't have x, so this is going to be a constant. The derivative of x cubed with respect to x will be 3x squared minus the derivative of 17x with respect to x will be 17, and the derivative of a constant is 0. This is going to equal 3x squared minus 17, which is exactly what we found when we applied part 2 of the theorem. And that's why we will always have the endpoint x, because when we substitute a, which is a constant, it's going to be a constant term. And the derivative of the constant term with respect to x is going to be 0. Now we want to evaluate little f prime of 1. So little f prime at x equals to 1 is equal, it's going to be this function at x equals to 1, 3, 1 squared minus 17, and this is going to be equal to negative 14. And we are done. I hope this video was helpful. See you next time.